Hello, all, and thanks for coming to hear me while you eat lunch today. Um, so, uh, and thanks also to Open Planetary for the opportunity to talk about this new visualization that I put together and kind of the context and path forward for this family of tools. So first, I'm going to motivate this in the context of my current work, which is mostly Earth focused, and then jump to kind of how this fits into Mars, and then talk about the actual software that I'm working on. So right now, I am a research scientist at the University of Wisconsin working in the Macrostrat lab, which is under PI Shannon Peters, who comes out of paleobiology and is very Earth-focused geoscientist. And this Macrostrat project is basically a terrestrial database of stratigraphic columns and geologic maps. So geologic maps across the globe, coupled with stratigraphic columns going down into the crust in a lot of locations on the globe, mostly focused on North America right now, but kind of expanding. And the goal is really to build a 3D crustal architecture of the Earth's crust. These maps and stratigraphic columns come together to form essentially a model of the Earth's crustal volume through geologic time that's strongly tied to the initial data. And so you can do big meta-analytical things like the proportion here of shallow marine sedimentary rocks that are carbonate stretching back to the Archean. So that's motivated a lot of kind of big science things, but one of the other things that we can do with this type of data set, and one of the other big motivators, is that we can build user interfaces over geologic data that provide a lot of value to kind of communicate science and encapsulate science and link between scientific artifacts. And that's really where I come in. You know, I've been interested in data visualization for a long time, and that has been part of my Mars work as well as my Earth work. And another thing that we can do with data visualization, and one of the things that I'm really keyed into, is creating new ways of viewing and manipulating geologic data that are kind of by and for geoscientists. And building these in such a way that they're composable so that you can use software libraries that fill multiple uses and can be remixed into different products. So this is kind of one toy example from Earth, which is basically we can render a regional stratigraphic column on the left of one basin in the Western US, and then we can use the same library and tools to render a stratigraphic editor that works in the browser to kind of create data associated with measured stratigraphic columns. So this is kind of a small example, but this is the motivating idea of how I kind of am trying to structure user interfaces. But that brings me then to visualization work and visualization and really where that started for me was on Mars. Unlike on Earth, we can't do field geoscience effectively on Mars by going up to the rock and looking at it and kind of driving around the region. So our interaction with our study area necessarily has to be digital. And so my study area for part of my PhD, the half of it that was a Mars study, was kind of south of the proposed Mars 2020 landing site in this area that's kind of referred to as NE Syrtis Major. And there's a pretty big stratigraphy in NE Syrtis Major that goes from altered Noachian basement up through olivine carbonate altered rocks, then to kind of a more sedimentary stratigraphy capped by Syrtis Major lavas, which I focused on. And so part of this work was to build regional scale elevation models, which are, you know, started at high rise, and then, you know, we kind of got ambitious and built a big 20 image CTX mosaic, which surprisingly worked in socket set, but took a lot of grief back in 2015 and 16. And then, you know, we kind of augmented that outside of this area by HRSC imagery and MOLA. And the initial reason for doing all of this elevation modeling, and the initial focus was really heavily on high rise, and it was to do really detailed scale orientation analysis of topography, looking at bedding orientations across the sedimentary units in the upper stratigraphy of Northeast Syrtis. But one interesting thing that came out as we were writing this up was actually that a lot of our key findings, especially from like geologic relationships, unit relationships and timing, came just from looking at the draped 3D imagery on kind of high resolution topography and making geologic inferences in a very familiar way to any Earth scientist who's operating on Earth, looking at field relationships and saying, okay, there's a lava flow flowing through this valley that's walled by this other capping surface that's partially eroded, and there's river channels kind of cutting down through this stratigraphy. And then we can do the same thing in even more complicated geologic relationships and start to speculate about very fine-grained flow directions and inverted topography where Syrtis Major lavas are now tops of mesas where originally they were flowing through valleys. And so these types of geologic relationships are absolutely critical for understanding how pieces of a regional puzzle fit together. And they really were built on top of these large-scale topography products that are, cover 100 kilometers wide by 300 kilometers north to south. So that's kind of the context in which I started working on 3D terrain visualization in particular, was working on this Mars study. And basically with that, it was kind of working at Caltech in the Murray visualization lab and other labs on campus, and working with this Fiddleaf software that was socket set and some other 3D viewers. Open Scene Graph and OSG Earth was another major component that I fiddled around with that actually produced these visualizations. And they're really good, but they were very time consuming to create. So it's always been kind of in the back of my mind that building something that's a little easier to maintain as a as something that we can build on over time that doesn't break and require C++ programming every time we try to recompile it is something that will really help us out in our Mars science. And so that kind of led to some, this is just kind of the products of that study, which are a geologic map, which we were able to go in great detail, partially because of these regional contextual products. And then a pretty detailed framework for the geologic processes and their timing. And a lot of that came down to, some of it came down to the detailed observations, but a lot of it came down to the regional observations. So from this kind of study, I basically came to the conclusion that regional context is very important, and we should be striving to represent that as well and at as large of a scale as we can, in all that we do. And that's actually a critical science task. So then moving back to Earth, we have this global compilation of geologic maps. And one of the things that we've always wanted to do with it has been to just represent it on the terrain which it describes. And this is a valuable thing for science communication. And so earlier this year, kind of with the prompting of some other people in the community who are working very successfully with cesium JavaScript renderer for terrain, among them, the MMGIS project at NASA is using cesium, and Mars Trek and Moon Trek and that whole family of projects are using cesium. But it seems like you could use it for very high resolution topography. So we started playing around with that at MacroStrat and quickly found, yeah, this seems like a viable path. In fact, we can have a lot of control over it that we wouldn't get with something more off the shelf like Google Maps. And so we can put it in our own interface, layer on Bedrock, which now seems to not be cooperating. This, by the way, isn't a public product. This is something that's in development locally. So it's a little sketchy, but this is kind of the status on Earth. And so, yeah, we can layer on our bedrock geologic map. And because we put in a lot of work on the data backend side, this is something that is a global product that now we can have a global geology viewer. And the big problems become, okay, how do we make sure that we don't kill our servers and do this in an efficient way so that it doesn't cost us lots of money in hosting fees and that sort of stuff. But the technical tools to do something really, really profound are in reach here. And one of my reasons, a big one of my reasons for pouring a lot of effort into this was thinking about the Mars science side, where this is not only great for communicating the science, but also great for just, you know, doing the science in the first place, essential really. And that brings us to the subject of this talk, which is this, this viewer that I basically put together over the course of about a week using the exact same innards as this macrostrat terrain renderer from Earth, which is basically a cesium.js backend coupled to some kind of very opinionated choices for how to render topography using Mapbox Terrain RGB and some other products that they're working on at Mapbox, coupled with the data products that we have for Northeast Syrtis. And so this is a pretty powerful viewer built on top of cesium. And you know, it's certainly something that could form the core of an application geared towards, you know, geared just towards being a map application. But one of the things that I did was I put this in the context of kind of a science essay, just laying out in fairly technical terms the details of Jezero crater, its kind of regional context, its river system, outlet channels, and moving through this fast really pulls down a lot of data quickly. So it takes a bit, but anyway, we can fly around the river system, fly upstream, and each of these text elements is basically tied to a position that it will fly you to during that, you know, as you scroll to it. And kind of the reason for putting it in this format was I wanted to emphasize that once you have a good component for building interfaces and you design it carefully so that it's portable, you can layer it into a lot of different ways and a lot of different viewers with a lot of different goals, essentially. And you know, this viewer with the goal of just representing the context of the Mars 2020 Perseverance mission would work scale viewer focused on Earth geology. And this is kind of basically, you can fly around to all the different areas that are, you know, that I have deemed important for understanding the regional geologic setting. And the data is kind of limited in scale such that it's only a like 2 degree by 2 degree swath of the Mars surface. But it kind of basically leads you to the end. And then there's only one instance of this in the viewer right now. But one of the big powerful pieces here is that we can change layers and add in our own layers and different data than just the base map and topography. So we can imagine adding eventually things like high-rise imagery in more detail. We can add turn on and off chrism layers, even add annotations. That's kind of the goal here, is to build build something that's really customizable, and then be able to layer it into interfaces that are maybe focused on Northeast Syrtis, focused on Mars globally, focused on you know, specific showing specific data products very well, or even something that's more interactive for the user, where they can you know, pick different field trips and kind of view them. So there's a lot of opportunity here for a lot of different things, and part of my goal in this is to show that we can put two very different things, an essay about the regional history and a 3D terrain viewer side by side, and that will elevate both pieces of the product. So kind of going from here to what I think this means, and kind of some calls to action for the community. So first we can talk about, like, why go this route? Because it requires a lot of building software and a lot of using my time as a researcher to build JavaScript software instead of doing whatever it is that researchers are supposed to do. And kind of the context is also like, 20 years ago, ArcScene kind of promised that it would give us this kind of 3D capability. And like, what is different this time? And is this stuff going to just kind of fall by the wayside as technology changes, and we'll end up in a lot of wasted work? And so I think a few things have changed. And one of the things that has changed is that this tooling is pretty approachable to start developing with, even for geologists relative to the past. And also it's based on the web platform, which is kind of a universal rendering platform that is very stable through time, and kind of has a lot invested in it. So it's not like we're targeting just one software renderer that might get outdated and not be supported anymore, and only works on Windows or has to be compiled in a complex way. This is much more universal, and that was just not available to us, for a long time. So I think there's a lot of opportunity to think about using the web stack, not only as something that makes things accessible, but also as something that just increases the likelihood that your software will have longevity. And then thinking beyond just the viewing software. The hardest part of getting this all together, and part of the reason that I was able to do it, is I had a lot of these data products from my PhD work sitting on hand that I could change into Mapbox terrain RGB and put on a server and hope that the server didn't collapse under the load. But these data products are really the major barrier to producing this type of work at larger scale. We have a lot of very high resolution elevation models of portions of Mars, especially in the Northeast Syrtis region and elsewhere where we've landed, such as Gale. But what we really need for geologic context is multi-scale products that are aligned and cover large areas. And this would prioritize wide availability of data over precision. Because we're, kind of de-emphasizing precision, there might be more opportunities to automate processing of this type of data. One of this kind of approach has been demonstrated on imagery, and just CTX strips by the Caltech Murray Lab with their CTX global mosaic, which is used to great effect here. And I know others in the community are very interested in this problem because that's kind of something that Open Planetary itself has hinted at with the Open Planetary Map project. So that the trick is expanding this stuff to go from global scale down to really detailed scale, where these multi-scale software viewers can really shine by showing context at different scales. But this is a big community level problem that we need to work on. I'm open and eager to collaborate with people on that. So on the viewer, other next steps that kind of are really highlighted by where we are with the current application are adding different map layers, being able to pull out Chrism, for example, and say, these are the mineral detections that we're using to say that this boring looking basement is actually one of the most interesting places on Mars. Annotations would be another very good thing, so that we can highlight to especially non-specialist geologists the delta deposits here, these mega breccia blocks here, Those types of things will be very useful. And they will be useful outside of the context of Northeast Syrtis as well. And then another thing, which kind of comes from our experience at Macrostrat, is it would be great to add in integration of mapping data, not just imagery data, to drive future viewers. And there's a lot of geologic maps of areas around Northeast Syrtis Major in particular, because it's long been known as an exploration target. And these maps cover adjacent and sometimes overlapping areas, and deconflicting them and building a regional product would give a very impressive and highly explanatory base to communicate geology in this kind of framework, and would eventually lead us potentially down the path that Macrostrat has taken to doing large-scale analysis over composite products. So that's another big effort that could bear a lot of fruit in the Mars community. Then just kind of rounding out with next steps that we're taking on Earth, and maybe this is actually something that's much more similar to the Jezero viewer application, is we already have this interface that's coupled to an iOS and Android app called Rocked, which is to curate geologic field trips and show kind of a GSA field guide style of set of field stops and information about those field stops from the field kind of on a map. And building more advanced 3D viewing capability to kind of fly around your field trip is something that we can all see the value of, especially while we're stuck indoors and not traveling to cool field sites for the foreseeable future. So that's kind of what we're working on Earth, but these capabilities all feed off of each other. And so I can easily imagine something similar being deployed atop rover data on Mars. Mars Trek has kind of worked in that direction. And so these types of things are very possible and can elevate both Earth and Mars science. So that is what I have for you guys. So I'd be happy to hear any questions or comments. Thanks a lot.